Who is using MySQL? Who is using MySQL 5.1? MySQL 5.5? Okay. Good. You should know who I am. I worked at Continuum. Before that, I was working with MySQL, the project, and before that, I was a consultant working with MySQL and doing some consulting work. I've been in MySQL community for a long time, and I have a blog. If you want to keep up to date, this is the place you should look at. I'm going to do a quick refresh of the basic features of MySQL, so you will better understand what the new part is. And then we talk about what is new in MySQL 5.5. So first of all, MySQL main features. MySQL is famous, is the most popular database in the world for a few reasons. The reasons are because MySQL is easy to use, it's reliable, and it's fast. There are databases that are better than MySQL in some of these issues, but none of them is better in all three of them. So most of the people use MySQL just because it's easy to use, and many people use MySQL because it's easy to find compared to other things. In addition to the main features, there are also other things that were added later on after MySQL became popular. We have store routines, triggers, views, information schema, and so on. So installation of MySQL. Installation is easy. In Linux, you just do a apt-get install MySQL Server or yum install MySQL Server, and you are done. But the thing is, even if you don't have Linux, you can install MySQL in less than 15 minutes. This was a goal of the owners, of the creators of MySQL, and I think they were very much successful in this. The second thing is that the database should be transactional. So this was a sore point at the beginning of MySQL, because the usage of non-transactional engines was encouraged. Now, the way the web works today is that you should use UNDB, which is a transactional engine of MySQL that has everything that is required by a modern DBMS. So you can have transactions, translation, integrity, and your data is as safe as with any other database. The other thing that made MySQL wildly popular is replication. Replication, what is it? Basically, you start a business, a web server, anything like this. You have a server and you have a database with the data that is used by the server. When you start your business, this is what you need. You're happy, your customers are happy, everything works fine. Then you have more customers, more users, then you need to scale the web requests. It's easy again. You take more web servers, you put a load balancer in front, and everything is fine until you have a problem in your database. So the database is too busy keeping up with the data because you have too many web servers, so I cannot cope with the request of all these things. So this doesn't happen overnight. Basically, it starts happening when you become successful, when you have, let's say, 10, 15 web servers instead of one. So you have a problem. And when your web database server is too busy, it croaks. So what can you do? You can use the simple solution that you buy a bigger database server. It costs you money, but eventually you will be back at the same problem, that the bigger database server will be too busy and you cannot continue scaling up because it is going to be too expensive. So what do? You use replication. Replication works this way. You send all the updates to one server that is called the master, and you split all the reads across many databases that are called slaves. And the data is sent from the master to the slaves behind the scenes without your intervention. The principle is that what you have written to the master will be available in the slaves shortly after that. So your application now can scale. You have a master, and when your reads are going to be too much, then you just add more slaves, and this scales very well. This is the recipe used by web properties like Google, Facebook, Wikipedia, and let's say 90% of the most successful web sites in the world. The difference between what I do and what Google does is that when I have a problem, I have 2 slaves, 10 slaves. When Google has a problem, they have 1,000 slaves. That's more or less the problem. So, what do you do with replication? You make database handling a little bit harder, because you have to split between between writes and reads. But you have a lot of improvement on many aspects. For instance, you can recover from a crash. If your master crashes, you have a slave that is ready to be used as a new master. If you have a failover, you have a slave again that you can promote. Using the binary log that is used for replication makes you makes your backups easier to recover to the point in time when the crash happened. And of course you can increase your readability, the reliability of your system with many slaves. Another thing that is crucial in MySQL 5.1 is partitioning. Who is using partitioning? Not usually. Yes, maybe all you do, Marcus, I know that, because you have problems.
No, not too much with it.
Yeah, okay.
But now it's running, so that's why I'm not doing much with it.
If you have ever used the merge tables, this is a hack that has been in MySQL since version 3.23. It's a trick that makes you join tables almost transparently. So you have separate tables, and then you create a merge table that is the union of several tables. This way you can query this big table like it was a single one. The problem is that the tables inside are separated, so you have risk of duplicates, and if you want to insert it, you need to insert it in the tables themselves. You cannot insert it transparently into the merge table. You can, but you have to choose if you want to insert at the beginning or at the end of the union, so it's not really flexible. Instead, if you have a partition table, the partition table looks to you like a normal table, looks and feels like a single table. You can add a primary key so you don't have a risk of duplicates. You can insert in the table, and the partitioning engine will do whatever is necessary to put your data, save your data in the database. So how does it work if you have a table without partitioning? When you use the table, you have to look through all the table. And if you have indexes, you have to look through all the indexes. So it's going to be a large operation that the database server has to do to find the records. The same happens if you, instead of a single record, you have to look through the database to find a range of records. So the difference is this: if you have a partition instead, you have to look only at the partition where your data is contained. It works almost like an index. So if you say, I want this particular column, the range of search will be only within the partition. It doesn't look at the whole table, meaning that it will read from the disk or from memory only that portion of data that is relevant for that query. Reading less, the query will be faster. Same happens when you have an index. If you have an index, it will only read that portion, the portion of the index that is within that partition. If you have a range, you may have to read only one or a few partitions, and that contains all the records in the range that you are looking for. One example of something that you can do with partitioning. I took a database with 300 gigabytes of data, and to query this data using InnoDB takes 4 minutes and 30 seconds. To query the same data with MySQL takes 25 seconds. The difference is because I chose the data in such a way that the primary key doesn't fit in memory. This server has 32 gigabytes of data, and the primary key requires 40 gigabytes. So this is why you have such a long time with InnoDB. Using archive, it takes 22 minutes. Archive is an engine that compresses the data. Every query is a full table scan of a data that is expanded from the disk. Now, using partition instead, InnoDB, the query takes 13 seconds, MySQL 6.5 seconds, and if depending on how you partition, it takes also 4 seconds. In archive, partition by year, it takes 17 seconds, and partition by month, less than 9 seconds. Notice that archive takes less than MySQL or InnoDB without partition. There is one thing that you can do with replication and partitioning. In general, with replication, normally you use replication for spreading the rate, so not balancing. But you can use replication for other things. For instance, you can do backups. You can have a backup in a slave instead of stopping the master. So your system will continue functioning even during the backup. So the system is that you stop the slave, remove the slave from the load balancer, so nobody will be disturbed during the backup, perform the backup in the slave, then start the slave again, let the slave catch up with the replication, and put the slave back online. And during all this time, your master will be unaffected. Another thing that you can do is summary tables. Summary tables is something that you don't find in the database manuals usually, because you are breaking normalization. But it's very popular. It's a very popular technique because sometimes you need to do queries like which are the most popular ringtones in this website, and this means a very heavy query in your master, and you don't want to run this heavy query for every user that is opening your web page. So what do? You run the summary table with the statistic of your ringtones every 10 minutes, let's say, but you don't want to burden the master with this heavy query. So you let the slave do that. The slave will do this, will calculate this summary table, and then you will load the result only without the burden of the calculation to the master. The master will eventually replicate the summary tables, and every node will have the result in using replication, but only one node, actually one slave, will be burdened with the calculation. Another thing you can do is combine this technique with partitioning. You want to use InnoDB non-partition in the master, and then you want something that does your summary tables or statistics very fast in the slaves. So partitioning are very convenient for this, but you don't want to use them in the master because it will eventually add some overhead to it. So what do? You keep non-partition InnoDB in the master and partition the slaves. Perhaps changing the storage engine with something that you can dispose of, like MySQL. MySQL is very insecure, unsafe if you use it on the master, but if you use it on a slave, and you can eventually recreate that from backup in case something happens, you can do it. Nobody will suffer too much if you lose this slave, because you can recreate that. Even better, instead of MySQL, you can use archive. So if you use archive tables only to do statistics, this is very convenient, because every archive table is 1/10 of the storage that you use in InnoDB. So instead of being 1 gigabyte, it will be 100 megabyte. Instead of being 100 gigabytes, it will be 10 gigabytes. So since you have to read 10 times less, the query will be at least 10 times faster. Okay, that was a refresher of what you can do with MySQL 5.1. Questions? Let's get into the topic, MySQL 5.5. So, this slide was old, I didn't update it, but anyway, MySQL 5.5, the 8 is the GA version that happened in December. Now I think we have MySQL 5.5.11, And there are several good things. The first thing that you will notice using MySQL 5.5 is this: performance. MySQL 5.5 has the default engine InnoDB instead of being MyISAM. And this is not only the default engine, but is the default engine that has been improved a lot. In MySQL until 5.1, you take InnoDB and you have to tune it a lot before it becomes performant. In MySQL 5.5, the defaults are already almost tuned. So if you just change from MySQL 5.1 to MySQL 5.5, your application will be at least 20% faster. Depending on what you are doing, they could be even 30% faster without doing anything except changing from MySQL 5.1 to MySQL 5.5. This looks like magic, but it's just the result of hard work of the engineers at MySQL that have done good work of a good job of focusing on the main need of performance that people were asking for. The thing that you see in MySQL that is called InnoDB is actually a plugin, and the plugin has a version. So you will see, in addition to the version of the database, the version of the plugin itself. In MySQL 5.1, the plugin is something that you can get separately and then plug in to the server. Instead, in MySQL 5.5 is already in.
In later versions of 5.1, it's in there. Like anything after 5.1.32, it's
It's there.
default. Yeah, it's default in there, just like 5.5. You don't need to get it in, especially.
Really?
Really.
I mean, until December was not.
Well, it wasn't included.
It was from like, yeah, for a year or two it's been in
No,
the
no, no. It's not like that.
Okay.
Now, the plugin is there, but it's not the default.
It's not the default because MySQL is the default. But the
No, it's
plugin
not.
itself is.
No, it's not.
Was
Okay.
not the
We can disagree and look it up later and then have a.
Yes, I'm pretty sure of that because I tested it until December when I did this presentation for the last time. So basically what you have in 5.1 is the default, is the built-in InnoDB and the plugin. And you can install the plugin, and actually if you install the plugin, you see the difference. So if you do a benchmark with the built-in InnoDB in 5.1, and then you do the same after you install the plugin, you see that you have between 10 and 15% improvement just without doing anything else.
I may be thinking of the Percona 5.1, thinking that might be, and that's what you.
If you are talking about Percona, yes.
Oh.
That in the Percona server, you have the InnoDB plugin as the default InnoDB engine. That's not in the good old MySQL installation, just because it is GA and they cannot change it during GA. InnoDB, so it's faster. You have performance improvement a lot. So it's not only is faster in day-by-day queries, but it's also faster when you scale out. So compared to InnoDB in 5.1, where you can scale up to, I think, 4 cores, in 5.5 you can scale up to 16 or 24 cores. How much was it, Massimo?
So before for 5.1 was 8 was maximum, then the performance was
Yeah.
was flat, and in 5.5 we can arrive up to 32,
Really?
and with the linear scaling more or less linear. Then between 32 and 64 there is a little improvement, but not very linear. So
Okay. So it's even better than I remember. So I was following when the developers were improving and improving. So I remember apparently they managed to do that
Yeah.
even with 32 cores. But you know, if you just want to do the magic of improving an existing application, it's easy. You just change it from 5.1 to 5.5 and you have magically between 10 and 50% performance, depending on what kind of queries you do and what kind of scalability you need in your hardware. If you are good at tuning databases, I have reports of people who have done a lot bigger improvement using MySQL 5.5. You have to study a little bit, but even without studying, you will be satisfied if you do it. Now, if talking about the performance, there is one new thing that is called performance schema that helps you define where you need to tune your database. So, what is the performance schema? It's a tool that allows you to monitor the inner parts of your database server and to find out what is going on in some parts of the performance and to get a very good idea of what you need to tune later on. So, using the performance schema, you can get specific information about the very detailed part of the InnoDB system and a lot of other things that pertain to the whole server. This performance schema is expensive, so if you try to monitor everything, you will have some overhead. To help you try to find out exactly what you need, the performance schema allows you to decide which parts you want to monitor and which parts you want to avoid. For starting, you can say, I don't want the performance schema at all, so you will have zero overhead. Or you can say, yes, I want it, but I want to see only this particular aspect. So you enable that, and then you run the database, and you see the results. We have seen partitioning before, and in 5.5 you have some improvement for partitioning. The thing that was bad in MySQL 5.1 for partitioning is that you can partition only by integer columns. Now you can partition by several types of columns natively. If you wanted to partition by date, by a date column before in 5.1, you have to do like this. Partition by range, using a column. The column converts a date into a number. And then you define the ranges. Again, you use the function and put the date here, the function, put the date, and so on. What happens here? Not only is long to write, not only you are forced to use only this function, because if you use other functions, it doesn't kick in. But when you ask the database what it has stored about this partition, you get things like that. Look here, you have 2007-0101. After, when you ask the database, what did you put inside, you get 733042. And this is not the idea of how human beings communicate dates. So this is bad, and you can, there are workarounds, but you know, it's not something that you want to see. So in 5.5, it works like this. You don't need to use a function. You put directly the column name. You say 2007-0101, and after, when you ask What did you put inside? It tells you 2007-0101, which is one step ahead in the understanding between computers and humans.
Does partitioning, do you still need to be part of the primary key?
Yes, but the limitation has not been lifted. Another thing that you can do, you can use more than one column. So in MySQL 5.1 you can partition by one column only. In 5.5 you can partition by several columns. So instead of saying less than this column, you say less than this tuple. So it's a record composed of several values. An example of how you can use this partition with several columns is this. You have an employee table where you partition by gender and hire date. The first partition tells you we have all the female employees hired before 1990. The second is all female employees hired before 2000, and then all the other female employees. Then the fourth one tells you all the male employees before 1990, and so on. So as you can see, it makes your information easy to read and easy to partition in a natural way. It's not always like that, but you get the idea. In addition to that, you have a function that is truncate partition. Before you have to drop the partition and to recreate that, but to recreate the partition requires an alter table, and this is an expensive operation that may take long time. Instead, with truncate partition, you just remove the data and leave the partition like it was before. We have also a 2 seconds function that does the same thing as 2 days, but instead of giving you days, it gives you seconds. Signal. This is something that people have been asking for since 2003, when MySQL 5.0 was announced. When you have an error using stored routines, there is no way that you can do something like exception handling in languages like Java, Python, and Ruby. Now you can do something like that using signal and resignal. So you can handle an error using these 2 commands. You can create an error using signal, and you can create a different error using resignal, and eventually handle this in the store routine that called the previous one. An improvement of replication comes with semi-synchronous replication. In order to use semi-synchronous replication, you need to install a plugin. It's not on by default. You have the plugin, but you need to tell the master and the slave to load the plugin before you can use it. So you install a specific plugin for the master and a specific plugin for the slave, and then you have semi-synchronous replication enabled. What happens when you commit statements with replication? You send a commit to the master. The master puts the commit in the binary log, and it goes to the relay log, confirm the log reception, and then it goes back to the client. Now, this is what happens with semi-synchronous replication. If we go back a little bit, when you commit to the binary log without semi-synchronous replication, the master tells the client it's okay. But the data has not gone to the slave yet. So if the master crashes in that precise moment, after it has told the client it's okay, and before the data has reached the slave, you have a very unpleasant situation where your record is lost and you think it's safe because you have received the okay from the master and you don't know that it was lost. Instead, after semi-synchronous application, the master sends the record to the slave saves it, and only after that the master tells the client it's okay. So if the master crashes in that moment, you will lose a record, but you will know about that. So you can retry. Your application will say, okay, this was not successful, I can go on and try once more. We're almost there. So I want to talk briefly about something that is as important as the things that we have seen for 5.5. It's a GA release about MySQL 5.1, meaning that as of MySQL 5.147, there is a plugin, InnoDB plugin, almost the same thing that you see in MySQL 5.5, and you can use it immediately if you are using MySQL 5.1. So the difference is this: you don't have to do a full upgrade. You just have to change the InnoDB engine. So the plugin, what is it? It's a piece of software that you can eventually put together with the server, and you have the InnoDB that looks and feels like the native InnoDB. In addition to that, the InnoDB plugin comes with a lot of information schema tables that give you a lot of insight into the performance of any InnoDB. How do you install this? You have to modify the configuration file. Inside the MySQLD section, you put a plugin dir information. You put an instruction that is called ignore built-in InnoDB, meaning that you have to tell the server, don't use the thing that is compiled within, and load the plugin named HA InnoDB plugin. Then, just to be safe, you say default storage engine InnoDB. You use InnoDB file per table, because in this way you can have the full advantage of the plugin. You change the InnoDB format. If you want to be safe, you also say strict mode equal 1. And actually, if you want all the information schema tables, you have to say all these things in one line with no spaces. Don't worry about that. This is in the manual, so you can just cut it and paste into your configuration file. But you have to make sure it's all in one line with no spaces. Then you restart the server, and it is done. There is another method that you can use instead of doing everything in the configuration file. You just put ignore built-in InnoDB, then you restart the server, and you load the plugin using SQL. The result will be eventually the same. The difference is that with this method, you will put the information inside a table that will reload the plugin when you restart the server, even if you don't put the information in the configuration file. Then you have to restart the server once more, in this case, and put the same information that we did before, like the default storage engine, file per table, and so on. So the difference with method 1, you have to restart the server only once. With method 2, you have to restart the server 3 times. But you have the information stored into the plugin table. This is easier to write. It's maybe longer. Anyway, it's up to you to choose. You have to be careful though. Only the new tables will be created using the plugin. The old tables will remain like they were before. So if you want to get the full advantage of the plugin, you have to make a dump of everything and load it again using the plugin. But be careful that if you uninstall the plugin and go back to the native InnoDB, this is not compatible with the new data. So if you create a table with a plugin, the InnoDB built-in engine will not recognize it. So always have a backup. Now, I think I have gone to the end of the allotted time. So I will skip the example of how to use InnoDB plugin with MySQL 5.1. I think we have covered everything that we needed. So we go directly to the end of the presentation and questions.